So when you hear the term machine learning, what do you think of? Probably nothing, because it's kind of just an empty term if you haven't studied the subject, or if you don't even have like an inkling of what it's about. You probably hear it a lot, know it's being used in whatever product you're using, and that's as far as it goes. So let's just have a conversation around what it is, what it can do, and how you can get into it if you want to. Hey, what's up? It's Meezy, and today we're just going to be talking about all things machine learning. Now, this is going to be a pretty general, pretty brief overview, but I promise you're going to come out of it feeling like you are on top of the world. So before we get into exactly what machine learning is, let's talk about the history of machine learning. So we can roll machine learning all the way back to the 50s with Alan Turing, who dared to ask the question, can computers think? One way that he tested out his theory, or tried to answer his question, can computers think, was by developing the Turing Test, which basically he used to tell him if computers could actually think and behave like people. So the Turing Test is basically when you give a human a piece of text to read and you give them the task of determining if that piece of text was written by a human or by a computer. If the piece of text was written by a computer and the human cannot tell that it was written by a computer, then the computer that wrote that text is said to have passed the Turing Test. All right, so that is just an overview of it. Feel free to look it up. People do have beef with it, but like it or not, it is where a lot of the talk around artificial intelligence and machine learning started. So if we then go a little bit further into history, a little bit deeper in the 50s, we meet a man called Arthur Samuels, and he built a machine that could play checkers, and this machine would eventually be able to beat him in a game of checkers. So through building this machine and doing a lot of other research, he coined the phrase machine learning. So machine learning, like the concept, goes all the way back to the 50s and kind of all the way back before that, honestly. We can roll it back pretty far. If you want to know a little bit further in history, you can watch my last video about what artificial intelligence is. Okay, so from the 50s to the 80s, or to the 70s, from the 50s to the 70s, we made a lot of advancements in machine learning. A lot of the algorithms and techniques that we use today actually started being developed back then. We had the computers that could play games and beat humans at them. We had computers being people's therapists. We had computers that could just do, little tasks that at the time we never felt like a computer would be able to do that. And so everything was going really well until capitalism stepped in. The businesses said, hold on, wait a minute. You said that we were going to be able to do all these amazing things, and all I've seen is a computer beat a person at games, and that's not very helpful, and that's not going to make me any money, so I'm done funding this. Now that is not completely factual, but it is what happened for the most part. People just stopped doing research because they felt that people overpromised on what machine learning could do. But the real reason behind that, why they felt like people overpromised, was because they were making a lot of advancements really fast as far as like theory and conceptualization was concerned. They had a lot of ideas of what to build, but they did not have the technology to build it. So their ideas were outpacing the technology that they had at the moment. They did not have enough computational power to build the systems that they were trying to develop. And then secondly, they just didn't have enough data back then. This was before smartphones. This was before we spent our lives glued to screens. And so it was really hard for them to get data. They just didn't have enough. So those two things combined led to people feeling like the researchers, the scientists, all those people had overpromised on what this technology could do, and feeling like it was a flop. And so from the 70s all the way up to the 80s, we had what they call an AI winter, where very few advancements were made in the field. And then from the 80s to the 90s, there was an AI chill, same kind of concept. There was a little bit more going on, but still not much. People had kind of like given up on it, you know? But then the 90s hit and they said, you know what, we got to get the Avengers back together, because the computers finally got up to the speed that they needed to, or had the computational power that they needed to execute the ideas that they had. It was also a great time when they started learning how to gather data. Stuff just, the stars aligned, and baby, it was time to do some machine learning again. And so from the 90s all the way to now, we've been able to make a lot of advancements, do a lot of cool stuff with machine learning. So now you have the history. So what is the goal of machine learning? Well, the ultimate goal of machine learning is to build systems that can perform a task without explicitly The goal of machine learning is to build a system that can perform a task without explicitly being told how to perform that task. And that is why I say a lot of machine learning from today is not really machine learning, because it's just a bunch of if statements put together. And if that is the case, then you're giving the machine instructions and there's no machine learning going on there. But that's another story for another day. And so that is just the general goal of machine learning. And so there's a few subcategories of machine learning, and I want to talk to you about two of them today that are the kind of the very basics of machine learning, and that is supervised learning and unsupervised learning. So in supervised learning, you feed your machine learning model labeled data. So it's really about mapping one thing to another. So you will give your model a bunch of pictures of animals and they'll all be labeled. You'll give it a lot of pictures and you'll say, okay, tell me from these pictures what is a cat, and then you'll train your model and all that, and it will come back and be able to tell you, okay, this is a cat, that's not a cat. And that kind of problem is what we call a classification problem. And that is an example of supervised learning, right? Because we gave it data that was labeled. In unsupervised learning, we give our model unlabeled data. And so we give the model that unlabeled data, and we expect the model to tell us about the relationships in that data. Like what does that have in common? What's going on there? And an example of unsupervised learning, is if you were to take a bunch of news articles and feed it to your model, and then tell that model that it should put those articles in categories by topic. So just tell me how many different topics are in this data set and how many of the articles belong to those separate topics. So that is an example of unsupervised learning, and that specific task is called clustering. All right, so we know the history of machine learning, we know the goal, we know a couple of the subcategories of machine learning. So what does a typical day-to-day look like when you're building a machine learning model? Well, I'll tell you right now, you'll spend a lot of time playing with data when you're building machine learning models. So the first step is to decide if your problem needs machine learning. So once you decide what the problem is and if you can use machine learning to solve it, you're then going to go start gathering data so that you can build your model. Your model is only going to be as good as the data that you feed it. So you go off, you gather the data, then you look at it, you clean it up a bit, you take out any empty rows, any invalid values that are in your table, all that kind of stuff. You clean it up, you make it nice. That way your model is working with very good data, okay? And then you are going to do some analysis of the data, just see what are you working with, what's in there. You gotta look at the marble, you gotta date the marble, you gotta be the marble, really get to know your data. I was supposed to say know the data, date the data, be the data, but if you got the SpongeBob reference, click the like button. But anyways, so you do all of that, right? You gather your data, you analyze it, you clean it, you get it all ready to feed to your model, and right before you feed it to your model, you split it into two categories. You're gonna split it into training data and you're gonna split it into test data. So once you do that, you're going to decide what kind of model you want to build. So when you start your problem, you might not know what kind of machine learning model you need to use, what technique you need to use. Should it be unsupervised, supervised, reinforcement learning? Like, what should you do? Your data can kind of help you figure that out. So once you look at the data, you figure out what kind of model you want to build, and then you go train your model. To train your model, you use that training data that you created when you pulled out your data set, right? And typically you'll use about 70% of your data to do that. So you use about 70% of your data to train your model, and then you go and evaluate your model by feeding your model that testing data that you saved. So that 30% of that data that you saved for testing, you feed that to your model, and then you evaluate the metrics. So some metrics that you'll look at are precision, recall, accuracy, and F1 score. Those are the metrics that we use to score machine learning models. If your metrics come out exactly how you want to, then congratulations, you're done. But 99.9% of the time, that will not be the case. And so you'll look at your metrics, you'll say, I want to improve my accuracy. And so you'll go into parameter tuning, and you will change some things about your model, change some ways that your model works, and try to increase your accuracy. And you can go through that process a lot, right? So you can go through training, evaluating, and tuning a lot of times. You can iterate on that as much as you want until you get the evaluation metrics that you want. And then once you have those metrics that you want, you can start making predictions with your model. So you are good to go. You have built your model. Congratulations. And I want to reiterate that a lot of time that you spend will be with that data. Your model is only going to be as good as the data that you put into it. And knowing your data really well is going to allow you to be able to interpret your model. And I'll share one anecdote. When I was building my model for my capstone project in my machine learning bootcamp, it was kind of hard to tell if I had a good model because my data set had over 2 million articles in it, and I just didn't have the time to go through every single one. And so when I was getting my results, I was like, this just doesn't seem right, but I just had to go with it because I did not take the time to get to know my data. So don't be like me. Get to know your data, be able to build really good models. All right, so the last thing that I want to talk about is the kind of the different areas of machine learning that you can go into. And those are natural language processing, also known as NLP, computer vision, and recommender systems. These are just a few, but they're the ones that kind of interest me the most. So we'll start with recommender systems because they are the ones that affect our lives the most. That is an example of that is when you go on Netflix and it says, hey, you should watch this movie, you'll really like it. And it turns out you like that movie. It's because they've been looking at the previous movies that you've watched and they say, yeah, this one here fits that bill. We're going to send that to her. Or, there's computer vision, and Teslas use computer vision to tell what is on the road. So it uses the cameras on the cars, it's looking at what's on the road, and it's able to say, this is a stop sign, this is a cone, this is a person. It's able to avoid any obstacles as necessary or stop at stoplights, whatever it needs to do. And then natural language processing is anything that has to do with like speech or text and being able to interpret that and do computations or perform actions on it. So when you talk to your G Homes or your Amazon assistants or your iPhone assistants, it's using natural language processing to figure out what you are saying and what you mean by that and what it should do afterwards. So that is the basis of machine learning. I keep trying to get these videos under 10 minutes and I don't make it, but I hope they are super helpful for y'all. Make sure you watch all the videos in this series if you want to learn more about the world of artificial intelligence, machine learning, and data science. Oh, and if you are excited by this video and you want to learn more, check the links in the descriptions. I'm going to link a really good course for y'all. It's made by Microsoft. Yes, I'm a little biased, but it honestly is a great course and you should take it because it's free. Why not? All right. Thank you so much for watching and I will see you in the next one. Bye.